Okay, so here's the worked through answer for the first group activity. I'm going to cover both group activities in this particular lecture. So we are in the Perspective Matters Unit 3 ratios, proportions, and scale factors. And again, I'm going to cover the Boeing activity and the Starbucks activity here. So we started out with this mocha frappuccino from Starbucks, and we had this pull down menu, but the key information we were getting out of this was that a 12 ounce has 270 calories, 90 calories from fat, and then any other information will come grab as we need it. So as I go through this one, a proportion is going to be a statement where two given ratios are equal. So for 1 and 3, it asks for a proportion. So we're going to set 2 equal to get it. 2 and 4, though, just ask us for ratios, meaning we're just going to have a reduced fraction as our answer. So for this first one, it's how many calories would be in a venti? So first of all, when we're setting up our proportion, we want to make sure that our units match in a way that makes sense. So a 12 ounce has 270 calories. And I want to set up the other ratio to be the same unit-wise, just like you did at the beginning with the unit price. So I want calories per ounce for this second one as well. So in a venti, I do not know how many calories, but I know that it's 20 ounces. And when I'm labeling these, this column is my tall, and this column's my venti. And then if I'm going across, calories and ounces. So to make that look a little nicer, I have a proportion of 270 over 12 equals x over 20. And I'm going to do cross multiplication to solve this. So it's 270 times 20 equals 12 times x. So it's the 270 times that 20 equals 12 times x. And then we're going to divide by 12 to get the answer. So you can plug in 270 times 20 divided by 12. And when you do that, you will come up with 450 calories in the drink. And I always like to think, does that answer make sense? Back to my problem solving. It's a bigger drink, so it should have more calories. So that answer does make sense. Then for my second one, ratio means it's just going to be a simplified fraction. Okay. So I want the calories in a venti mocha frappuccino, which were 450, to the total intake of 2,000. So 2 tells me where that fraction bar is. So I'm looking for 450 divided by 2,000. And at this point, we're just going to reduce it down however you want. So one of them would be, I'm going to cancel out these. Make it go a little smaller. 9 goes into, let's see, we can take out a 5 out of each of these. So I can break 45 into 9 times 5. And I can break by 200. Oops. Into 40 times 5. So I can do, my ratio is 9 out of 40. Okay. And just to make it make a little more sense, if you take the 450 and straight divide it by the 2,000, you get an answer of 0.225, which is 22.5%. So the venti mocha frappuccino is almost a fourth of the suggested daily intake of calories for the day. Then if I keep going, we want another proportion because now we want to know calories from fat are in the venti. So what we do know is that there's 90 calories from fat in our tall. And we got that from the nutrition label above. So we want to figure out if we up it to that 20 ounce, how many calories from fat are in the venti. Now again, the calories are going across the top, the ounces across the bottom. The left side is my smaller one. the right side is my venti. So I want to make sure all my units are matching up. And then thinking from perspective, this should be a larger amount of calories from fat because a bigger drink should have more. So when we go to do this cross multiplication, it's 90 times 20 equals 12 times x, and then we're dividing. Okay. So if you run that numbers in your calculator, you get 150 calories from fat. And then for our last one, we want a ratio of fat. So the fat calories was 150 to total calories in our venti mocha frappuccino. So those were our fat calories from number 3. These were our total calories from number 1. And a quick reduction here says that it is 1 to 3. Okay. And again, you always want to put a ratio in simplest form. So we want to reduce that 150 and 450. Okay. Now I will say for 1 and 3, if you did the proportion a little differently, but you still ended up with the 270 times 20 divided by 12, that's fine. If I go back up to this definition, as long as this, okay, so it's as long as this A times D equals your C times B. If you did it a different way, but have those same numbers, aka you got the same answer, then you're fine. There's multiple ways to set up proportions. Just like this second one, your part 1 may look different than mine because there's 4 possible answers. So I'm actually going to jump to question 2 first. And it's circle all the proportions that are the correct representations of the problem, meaning there are actually 4 different proportions that will give you the correct answer every time, because what we're looking for is, does this cross piece match? Are you multiplying? In other words, does the setup make sense? So first, I'm just going to read through this and set it up the way I might want to set it up. So a Boeing 747 is 230 feet long and has a wingspan of 195. So that's the wing. So over here, the scale model, I'm going to put the length first, so 40 centimeters long. And then I'm going to put the wingspan on the bottom. And the reason for that is I need them to match across. So across here, I have the length. Across here, I have the wingspan. And then this is the plane. And this is the model. So I should be able to make those same measurements and label in a continuous way that makes sense. So if I go to solve this, cross multiplication is going to give me this cross product of 230 times x equals 195 times 40. So any of them that give me that same cross product are going to be correct in terms of giving the same answer. So if I come down here, the first numbers I'm looking for, I need something that's going to give this cross product. Anything with a 747 is not going to work. That was the name of the jet. It'd be the same if I said it's just blue. It's not going to go in the actual problem. I'm looking for this 230. I'm also going to look at, can I label? So this 230 here, if we come back up, represents the length. Okay. So then this 195 represents the wingspan, so that's fine. And then if I come over here, X represents the wingspan, but 40 is the length. So that does not work. The measurements cannot go across. They either have to go a row or a column. So that one's a no. If I multiplied it, I get 230 times 40 equals 195 times x. Not the right cross product. So that one's a no. I'm going to erase just a little bit of this so it looks a little nicer for you. So that one was a no because I couldn't do the measurements as a column and a row in terms of labeling, and the cross product didn't match. So now let's go to this one. Let's take a look and just see if the multiplication works. 40 times 195 equals 230x. That one's good. Now, if I measured it, the 230 and the 40 both represent length. The 195 and the x both represent width going down. And then across, I have my real one. And then I have my model. So it works in terms of labeling. Over here, I get 230 times x equals 195 times 40. Correct cross product, so that works. That was the same one I had up here. And then these other ones are if you flip them. So at any point, you can flip both fractions. So f and d are just flipped, in which case the labeling still works because this is the real one, this is the model, this was the length, this was the width, just flipped. Oops, sorry. This was the length, this was the width. So that one's also good. And then h is b flipped. And again, the cross product matches. I get 40, come over here, 40 times 195 equals 230 times x. So the answers were F, B, D, and H for that one. Just making sure you have that correct. So up above in question 1, you could have done any of those 4. All of them are correct. So it's possible in your group, you all came up with different ways to set it up. But at the end of the day, if we go to solve it, all of ours are going to give us the same solution. So I'm going to go down here to H because it was also correct. So it was 40 over 230 equals, let's see, x over 195, multiply, and then divide by 230. So what I should come up with, I mean, I wrote that a little bit nicer, is about 33.9 centimeters. So if I take that and put it in terms of a theorem, as long as the cross product works, we're fine. So this A over B can be flipped at any point to be B over A, as long as you flip the other one as well. So as long as I get AD equals BC, AD equals BC, this is fine. And then I can also go across and rewrite it. So I could do A over C equals B over D because I still get AD equals BC. And then I can flip that one as well. And you don't need to memorize this, just know that you can write these 4 different ways. Okay. So then conclusion-wise, you should be able to label all your parts or match your parts, but they should match in terms of rows and columns, not crisscross. So if I write this as A over B equals C over D, I should be able to do an up and down on each one. I should be able to do across the top, across the bottom. So all of those should be able to label. So I should have a consistent label for all 4 of those that works. Okay, so you should be able to consistently label and look at that example we just did.